The existing approaches for identifying eating disorders primarily depends on the questionnaire-based screening instead of utilizing available neuroimaging modalities like electroencephalogram, E, magnetoencephalogram, MEG, functional magnetic resonance imaging, fMRI, etc. There is considerable research gap in utilizing intelligent mechanisms to address human tendency of excessive eating habits for coping up the stress. The eating disorder, ED, results in severe mental and physical complications like depression, anxiety, life-threatening obesity, and others. A. The presented work maps EEG recordings of participants with their scores of 3 factors eating questionnaire for identifying the possibility of them being affected with ED. B. The proposed approach tests the applicability of convolutional neural network CNN and long short-term memory LSTM for this classification task. C. The comparative analysis of the presented framework with existing solution proves its effectiveness for distinguishing individuals having traits of BED. The proposed model needs EEG and German version of TFEQ-Frage-Bogen zum Verhalten, termed as FEV, of the volunteer subjects for initiating the investigation of BED-related traits in a human. These health parameters are preprocessed that involves applying sliding window approach on EEG for generating its multiple chunks and mapping FEV scores to 0 or 1 based on the threshold analysis. Further, the presented deep learning model, comprising of convolutional neural network CNN and long short-term memory LSTM, is trained with these processed sample data set for the mentioned classification task. The performance of the CNN and LSTM modules provided in the proposed model is analyzed for the convolutionally encoded peak features. It indicates that LSTM-based model does not perform well compared to CNN-based model. That may be because of extensive tuning of hyperparameters like the batch size, optimizer, and others in the later case. The opt-in results for CNN and LSTM modules of the proposed methodology is compared with the state-of-the-art method RAB, D, Baumgartel, H, and Buettner, R, 2020, June, machine learning-based diagnosis of binge eating disorder using EEG recordings in PASES, P. 97. This research article presents an argument that EEG recording of a participant may be used to find whether the subject is affected by BED or not. The methodology employs end-to-end deep learning approaches and exhibits improvement over the standard approach with a significant increase in classification accuracy,